In this lesson, we are going to learn about constants, variables, and expressions. Variables and constants. A variable is anything, like a letter, that can stand for something else. For example, x, which is the most commonly used variable, can stand for anything, like the number 1. A constant is a value, like a number, that stays the same. The number 1 is a constant because it will always have the value of 1. Operations. Just to review, there are 4 major operations in math: addition, subtraction, multiplication, and division. Multiplying a constant by a variable. There are many different ways of writing the operation of multiplication of a variable and a constant. 5 times y can be written with no spaces, with the letter x, or with an asterisk sign, which means multiplication as well. Inverse operations. Example 1. Addition and subtraction. For example, when you're adding 2 plus 3, you can subtract 2 and 3 and get 0. Why do you think this is? Well, addition and subtraction are inverse operations, which means they can cancel each other out. This is what it means when they say they're inverse, because if you subtract 2 and 3, you get 0, but if you add 2 and 3, you get the same thing. Inverse operations. Example 2. Multiplication and division. Another example. When you're multiplying 2 and 3, you can divide 2 and 3 and end up with the same product of 0. Or you can multiply 2 and 3 and get the same problem that you first started with. Types of expressions. A numerical expression can only contain constants and operations. An algebraic expression is just like a numerical expression, but it contains variables as well. Example 1. Algebraic expression. Here we have the algebraic expression 2x plus 3. Let's break this expression down. As you see, the 2 in the expression is a constant, which will always stay the same. The x in the expression is a variable, which can change or differ. The operation of multiplication is used when we are multiplying 2 and x. The operation of addition is also used when you are adding 3, a counting number, to 2x. Example 2. Numerical expression. Here's an example of a numerical expression. 9 times 4 equals 36. As you see, there's no variables in their expression, but there are only numbers and operations. Transferring words to algebra. Dorothy is reading a famous classic, Moby Dick, by Herman Melville. Since it has complex vocabulary and isn't an easy read, at her pace, she is reading about 30 pages an hour, and started on page 14. Write an expression for the number of pages Dorothy can read in H hours. Now, here I'll explain how to transfer words into algebraic symbols. Let's first start with the information that we already know. We know that she reads 30 pages an hour. And we also know that she started on page 4. So we add 4 to whatever pages she reads in an hour. So, 30 pages times the number of hours, 30h, plus 14, can be written in the form of 30h plus 14, which represents the number of pages Dorothy can read when starting on page 14. Example 2. Solving algebraic expressions. Example 1. Solve this expression when given the values for x equals 9, y equals 5, and z equals 4. Now we're going to add values to these variables in the algebraic expressions. Instead of just classifying this expression, we are going to evaluate it, or solve it. As you see here, we have the expression x plus y minus z. Now if we plug in all the constants for which the variable represents, we get 9 plus 5 minus 4. As you see, 9 plus 5 equals 14, minus 4 equals 10. Solving algebraic expressions. Example 2. Solve this expression when given the values a equals 8, b equals 4, c equals 6, and d equals 3. Now we do the same thing. we plug in the values for each one. In this expression, A plus C divided by B minus D. Now, first we have 8 plus 6, which is 14, divided by 4 plus 3, which equals 7. And 14 divided by 7 equals 2. Thank you for joining me today to learn a little bit about math. I hope this extended your mind to what math is really like, and have a good day. So long.